Okay, so I've started recording. Yeah.
Okay.
So this is considered the first order derivative, which we have already discussed. Now, if you derive it again, this is the second order derivative. But this can also be represented like
Okay.
this. If this is function f, and obviously it's a function with respect of x, and then this is new function represented by f dash x, and there is some other function represented by f double dash of x. Yeah.
Yeah.
Now, for example, the question for you is this: like, if I gave you function or equation y is equals to 2x cubed is 3x squared is 9. Can you find d2y over dx2?
Yeah, I can.
Write it out.
Should I give you the direct answer or tell you the process and
Give me the
answers?
direct answer. Direct answer.
Okay, give me a second to solve it, I guess. So 2x cubed plus 3x squared plus 9. Okay, solve it.
So
Is it just uh 12x
first task is to find the dy
plus
by dx. Yeah,
1? 12x plus 1. Yeah. Yeah. dy by dx is 6x squared.
plus 6x. Right.
Yeah.
This one would be differentiating dy by dx again. You would get 12x plus 6. Is that what you got?
Yeah.
Okay. Now, what is the significance of this? Tell me. We have discussed the significance of this derivative.
Significance of derivative.
Of
Uh,
derivative. What does it
to
represent?
find the slope
Yeah, gives the slope of
of the line,
line.
straight line,
Which straight line? Tangent.
mm,
Tangent.
in y is equal to this.
Tangent. Gives the slope of tangent. That straight line would be a tangent at the point x comma y. Remember?
Okay.
It gives the slope of tangent. Yeah?
Yeah.
Any problem?
Yeah.
Now, what this gives you the slope of tangent. So if I say if a maxima or a minima is there, now what is a maxima or a minima? It's like a hump structure. Like when you have a value that is greater than the neighboring values. For example, this is a maxima. Yeah, because this
Yeah.
particular value over here is greater than its neighboring value. Yeah, this is a maxima as well.
Yeah.
Let me provide it. This is a maxima as well. Like this is a maxima as well. Yeah.
Yeah.
Similarly, there is something called minima.
Okay.
The minima is looks like this. And where is the minima? Tell me. The minimum value is here. And the particular value is greater than its neighboring values, then it's a minima, right?
Okay.
Now, what's special about these points is like if you draw a tangent at this point, it comes out to be parallel to x-axis, right or not?
Yeah.
If it's parallel to x-axis, the slope at the maxima or minima is 0. Hmm? Can you say that?
Yeah. Yeah. It's a straight line.
Slope. The straight line at every
Yeah.
point there is a slope. Here can also be a slope, but its slope is not 0.
Sir, If it's a higher power of like 4 or 5 and there's different curves and stuff,
Mhm.
we use the second derivation to find the maxima and minima.
You use secondary variation when if there is not higher powers, like you know, it doesn't matter if the polynomial function that you have is of power 10 or is of power 1. You can use the second order derivative to find out the maxima or minima. Let's first I'm just discussing the first order derivative now. Like at the points of maxima and the minima, can slope of the tangent is 0. Do you understand this point or not?
Yeah.
Only then we can move ahead.
One more time, can you repeat?
Slope of tangent at the points of maxima and minima is 0.
Yeah, understand that.
Yep. No. No. If someone asks you to find out the uh, slope of tangent, hmm? Like someone asks you to find out the maxima or the minima for a particular curve. Now, what will you do? What will be the first step that you should do? You will derive
Double
that. No,
derivation.
not the double derivation. You will first one derivation. You will first do one derivation.
Is it possible to directly do double derivation without doing dy by dx?
It's like asking, what are you asking? Like if I gave you a simple sum, you're saying, do we have to add 3 and then add 5? Or can we do it like in once? Like obviously if these two are added and only then if like the thing is the definition of double derivative is based on the first derivative. Double derivative is nothing but the derivative of the first derivative.
Okay,
Yeah, so you have to calculate the first derivative and then you have to do the second derivative. Like
okay.
if your mind works fast, then it's fine. You can do it in your head. But the process is this only. You
Yeah.
have to first do the first derivative and then the second derivative.
Fine.
Now, the question is usually the question that you will usually find is to find out the points of maxima or minima. Find out the points of maxima or minima. That's the question you will see.
Okay.
The very first step for that is doing first derivative. First derivative means the slope of tangent, right? Slope of tangent. Okay, find first derivative and equate it to 0. You get this step or not?
Yeah.
You first find the first derivative and equate it to 0. Yeah. Then you will get some values of
Yeah.
x. Yeah. You will get some values of x. Right. This
Yeah.
value can be a maxima or a minima. You're not sure because for both of them, the slope of the tangent is 0. Yep.
Hmm.
Right. To to know if they are maxima or minima, to know if they are maxima or minima, what do? You do the second derivative. Okay, do the second derivative. Know if they are maxima or minima, you do the second derivative. Yeah.
Yeah.
What do you do in second
If we
derivative?
get a zero, it is
So basically, you calculate
okay.
d2y over dx2. Okay,
Yeah.
and then you plug in the points. Plug in the points that are that you found. Like from
Okay.
here, from the first derivative, you will find some point, right? Like for example, you
Yeah.
found alpha comma beta. Now alpha comma beta can be a point of minima or maxima. To be sure about it, you calculate the second derivative and you put in the value of alpha comma beta in that second derivative and check if this thing is greater than 0 or is less than 0. If it's greater than 0, it's a minima. If it's less than 0,
Okay.
it's a maximum. You understood it?
Okay. Yeah.
Okay,
Understood.
so for this equation only, find out the points of maxima and minima.
Yeah. Should I substitute? What should I substitute x as?
See that step. What's the first step?
First, derive the slope and equate it to zero.
Yeah,
You
so what
will
you will
get some values of x.
so
Yeah. So the first derivative I did, and if I equate it to zero, is 6x squared plus 6x. You will get some value of x.
set value of x.
Should I do a quadratic?
Like, let's say some other equation and then if like quadratic is not a rule. Like if it's a quadratic equation, you can solve it. You will solve it using quadratic equation rule. If it's a cubic, you will solve it using cubic equation rule. So it is quadratic.
Okay.
You don't need to ask this question. The highest power of x is 2, right? And it's a polynomial. So it is obviously
So
quadratic.
x1 is -1 and x2 is 0.
Minus 1 and 0 are 2 points. Okay. Now find out the
Yeah.
coordinates of the points, which can be maximum or minimum. Find out that there are 2 points, so there will be two points.
X1 is less than 0, so it's a minima.
So-
It's a minima.
No, is that what's written over there?
No?
Is that what's
To know
written?
if they're maximum or minima, second derivative.
You have to find the second. First of all, find out the points. Find the
It's -1 and 0.
minus 1 and 0, yeah. Find out,
Yeah.
like, you can also find out the coordinates, alpha comma beta. If it's minus 1, what's the value of y? If you get the value of x, see, if you get the value of x from here, you can get the coordinate. Am I right or not?
Yes.
Coordinate. And I'm calling the coordinate as alpha and beta. Uh, can you no, tell me the coordinates?
It's -1 and 0.
Minus 1 and 0 are the two values of x. These are the values
Yeah.
of alpha.
Okay.
I'm asking about the values of beta. Is minus 1 in itself a coordinate or it's just the x
Beta
coordinate?
is 6.
Beta is?
6.
Doesn't seem like beta is 6. For what value of x?
How do I calculate beta again?
We found out the value of x. I'm just asking you to find out the value of y.
Okay. Okay, just substitute x in the formula.
Yeah. I'm just asking you to find the entire coordinate instead of just the x coordinate.
Okay.
Are you
So
following that alpha
I
comma?
substitute it in the second derivation, yeah?
No.
It's single differential derivation.
Yes. I'm asking the value of y only, na? For that curve only. I'm asking this point for you. You found out the x coordinate of this
It's
point.
0. If I substitute -1, it's y is 0.
I don't think y is 0, so you should x as -1.
Um, it's giving me 0.
Use your head
Next.
or use your calculator properly.
Okay.
Yeah.
6. 6 plus -6.
Are you putting the value in here, right? You're putting the value in here, right?
No,
Then where are you putting the value?
I put it in dy by dx.
Will that give you the y coordinate?
I had my screen zoomed in so I couldn't see that.
No, it doesn't depend on seeing. I'm asking you to find out the x coordinate, obvious y coordinate. You won't put that in dy by dx.
And
It it will obviously give you 0 because you have found out, you have equated it with 0 and found out the values of x. Now what you're doing, you're putting the values of x back in there, and obviously it will be 0.
yeah,
I'm asking you the coordinates. See, the values of x that came out are the coordinates of maxima and minima. Like, I don't know if they are maxima or minima yet until I do second derivation. What I'm asking you, like, if you have found out the value x, I'm just asking you to find out the y value as well, so that I get the entire coordinate, just not just the x coordinate. That's the simple thing I'm asking you to do. So you will just obviously put that value in the original equation of the curve and get the value of y.
here,
What is the value of y?
10,
And what is the other value of y?
0, 9.
So what are the two coordinates that we got?
-1, 10, and 0, 9.
These are the two coordinates only, right? Let's call it p and q.
Yeah,
Now these can be maxima or minima, but both of these points are at least one of them. Yeah.
yeah,
Now what is the second step? To know if they are maxima or minima, what do you do? Second derivative. This is the second derivative in front of you.
yeah.
Then what you have to do is you have to put the values of coordinates in the second derivative and check if that is positive or negative. So tell me, if is point P a maxima or a minima?
So,
And why? Like, the steps are written crystal clear in front of you. If you don't understand something, ask me. Just get
it's a minimum because it's less than 0.
it's less than 0, so it's a minima. Is that
Like if we put the 2 points on the graph,
the graph?
uh, I mean, one coordinate is minus 1 and 10.
Where are you putting the coordinates in? See the steps, see the steps. The two steps I've written.
Yeah.
What is the
To
second
know
step?
if the values are maxima or minima second derivative.
The second derivative we have already done. Then what you have to do is put the values of the coordinate in the second derivation.
Yeah.
What is the second derivative?
It's minus 6.
So minus 6. Is it greater than 0 or less than 0?
It's less than 0.
Is it a maxima or a minima?
Minima.
Which is the symbol of less than 0? The first one or the second one?
First one.
First one is saying less than 0. If I write x like this, it means x is less than 0.
No, x is greater. Oh wait, I saw the signs wrong.
Pay some attention. Is it a maxima or a minima?
It's less than 0.
So it's a maxima.
Yeah.
What about point Q?
Point Q is minima. It's greater than 0. Because it's 6.
Yeah.
Yeah.
Let's see if see in real. What was the equation? Plus 2x cubed
2x plus
plus
3x squared.
3x squared plus 9.
Yeah.
And see. This is the point of maximum, right? And this is the point
Yeah.
of minimum. Minus 1 comma 10. It was a maxima, right? Minus 1 comma 10. Set
Yep.
its maximum. 0 comma 9 is minimum. See, this 0 comma 9. It's a minima, as you can see. So if you draw a
Yeah.
tangent, it will be a straight line like this. It will be a parallel line like this. Okay.
Yeah.
Chapter review started. Is maxima and minima in the second book of yours?
What's that?
Is this topic like maxima and minima finding the extremums? Is it in the second book?
Yeah, I think so.
Okay. Let's see the second book. I think I don't have the second book yet. Have you sent me the second book?
Yeah, sent.
See. It's computer science. That's statistics. That's book two. Again, there's a differentiation in this as well, yeah?
Yes.
Differentiation. Yeah. So here is the questions related to maxima and minima. Modeling with differentiation. Okay. So we should just finish this differentiation with in hand, right? Okay. Because
Yeah.
there is no meaning of studying the same thing twice at different times. I don't know why your books have given like separated like two places, increasing and decreasing function. Okay, we'll say stationary points. These are called the stationary points. The local maxima, the local minima, or the points of inflection also are called the stationary points. Now, I've discussed about minima and maxima, yeah?
Yeah.
There's an inflection point as well. If the double derivative is equals to zero, then it's called an inflection point. Okay.
Okay.
Now, all these three combined are called all these three combined are called stationary points.
Okay.
Yeah.
Yeah.
We do this do for this one. For this one. हो सकता है एक मिनट कंट्रोल एम होगा शायद देख लेना ये मैंने चेंजेस कर दिया आइकन बदल दिए भाई का फोल्डर में क्या क्या चेंज और करना वो बता देना और उसका थोड़ा सा बिट बदल दिया है वो फॉन्ट चेंज करूंगा तो वो सबका हो जाएगा अलग अलग हेडिंग ठीक है फॉन्ट सही लग रहा है कर सकते हैं ऐसे फॉन्ट की चेंज वो उसका भी देखो बस उसके बाद देखते हैं उस क्लास का लॉगिन कर दिए सूरज बीच में
Find the coordinate of the stationary point on the curve with equation y is equal to x power 4 minus 34. Mm,
इस विंडो करेंगे
minus
इस विंडो करेंगे तभी काम करें
32x.
मेरे में तो बटन यूज करने का अलग से बटन दिया हमारे लोग
Can you
कंट्रोल
go to the question, sir?
मोटरोला 50 कंजूस भी रहेगा हमने बोल दिया अच्छा अच्छा बहुत अच्छा yeah this one
Yeah. Okay, find the coordinates of the stationary point on the curve with equation. Okay, by considering the points on either side of the stationary point, decide that it's a local maximum point of inflection. Uh, okay, so is this the entire question or is there a bit more?
the curve has been given to you you just have to find the stationary points You just have to tell if those points are local minima, maxima, or inflection. Yeah, this is the
Okay,
question. There is no other information.
okay, okay.
This
So
graphing
first
graphing
I'll
calculator allowed in your
begin
exams.
solving. No, not allowed, but you can take it then. If they catch you, you're done. But if they don't catch you, it's okay.
If it was allowed, like everyone would have, you know, there was no need to study these chapters.
Okay, so first, it's a fourth order. Do I have fourth order on my calculator? No, only up to three. Um, so first, I can start by deriving it. So it's going to be 4x power 3 minus 32. So dy by dx equals 4x power 3 minus 32. And then if I do second derivation, it's gonna give me 12x squared. Okay. Now, I have to solve the first equation. Should I like equate 4 to like power 2 or something?
No. What was the
No.
step is written for you.
First derive the slope and equate it to 0. Yeah, I derived it and I equate it to 0.
Look the values of x.
Find the values of x. To be honest, I forgot how to do mm, like after quadratic the cubic equation to solve it normally.
Cubic
Okay,
equation
one
shows
value of x is 2 and the other one is involving an imaginary number.
the two of them will involve an imaginary number. Just have to ignore the imaginary numbers.
Only one is involving imaginary number.
The third one will also involve an imaginary number. There will be three roots for
Yeah,
x.
yeah, yeah. There. Oh, yeah. There's three roots.
Like
Yeah,
the imaginary roots always exist in pair.
yeah. There's three roots. Two are imaginary. So what do I do? Next step is
What's the real root? What's the real root?
find y 2.
So alpha is 2.
So beta is x power 4. So 2 power 4 minus 32 times 4 minus 112. 112.
The coordinate is 2 comma minus 112. Yeah,
Yeah.
this is your alpha comma beta. What's the second step? Second
Second
step.
step is put the value of this in the second derivation.
So
So 2 squares 4, 4 times 12 is 48. Yeah, it's greater than 0.
so it is.
So it's minima.
Yeah.
Yeah. Do you know a game called Rust? No? Okay.
The coordinate that we found out is not correct.
It's not correct.
Here we'll put 2, not 4. Instead of x, you're putting 2, right? Why did you put 4 away?
I didn't put 4.
So how is it minus 1 over 2?
Um, not too sure. I think you did a mistake, sir, because I got minus 48 as a y.
So you should have stopped me, yeah?
Yeah.
Anyways, minus 48 as the value of y. The value of y doesn't matter because here you only put in the value of x. So it's a minimum, it should be a minimum.
Yeah.
The stationary point gradient on the other side from this. Okay, it's a local minimum point. Okay, what it is doing is it's doing a really different thing. You don't need to do that in exams. Okay, like it's using the concept of increasing and decreasing functions to find out this.
Oh, okay.
Okay,
But how, I think I learned this before, but I forgot now.
now there is something called increasing function and a decreasing function. Just
Okay.
yeah, it's all the applications of different derivative, increasing and decreasing functions.
Yeah.
Like you just have to know first derivative. So whether a function is increasing or decreasing can be just determined by the first derivative. Just the first derivative you can determine whether the function is increasing or decreasing. So how do you determine it? If slope of tangent or dy by dx obviously is greater than 0, then it's an increasing function. And if slope of tangent is less than 0, the function is decreasing. Okay, decreasing function. And if slope is equals to 0, and we have already discussed this, right? If it's equals to 0, it's a stationary point. It's a stationary
Yeah.
point which can be maxima, a minima, or an inflection. No problem.
No.
So just a question. Like for example, I gave you like let's take the previous example. That's x power 4 minus 32x. X power 4 minus 32x. At x is equals to 1. What is what can you say about the function? Is it an increasing function, decreasing function? What is it?
When x is equal to 1.
Yeah, just have to comment. What is it? Increasing function, decreasing function, stationary point.
Okay, so 1 second. Decreasing.
Increasing, so basically you differentiate it so you get the value. dy by dx as 4x power 3 minus 32, right? And
Yeah.
put in value 1, so negative value.
Yeah.
So it's a decreasing function.
Yeah.
What about at x equals to 3?
It's going to be uh it's going to be increasing.
The function went from decreasing function to increasing function. Yeah. So
Yes.
there must have come a point at which the value of dy by dx is equal to 0. There must be a stationary point. Like at x
Okay.
equals to 1, it was decreasing, while at x equals to 3, it was increasing. So somewhere in between 1 and 3, the function must be stationary. It must have changed directions. So let's so if it's a decreasing function, the function might look like this, right? Yeah, this is decreasing.
Yeah.
Yeah, because if it was to a tangent over here, the tangent is making an obtuse angle, and obtuse angle is negative slope. Yep, and it's negative. It's a decreasing
Yeah.
function, and then here it's an increasing function. It must have met somewhere here. So if it see this, let's draw the tangent. This tangent slope is negative, right? So this was the point x equals to 3. Sorry, minus x equals to 1. On this side, this is a positive tangent. Okay,
Yeah.
let's say that this side was x is equals to 3. Oh, sorry, x equals to 1. And this one was x is equals to 3. So it's a negative slope, it's a positive slope. So somewhere a slope of 0 must have come. And here is the 0 slope, yeah? It's a 0 slope.
Yeah.
So it went from negative slope to positive slope. Then it's a minima. If it goes from negative slope to positive slope,
Yeah.
then it's a minima. That's another way to find it out. And if it goes from positive slope to negative slope, then it's a maximum.
Yeah.
Yeah, that's what the book is using as of now.
Okay.
Any problem?
No.
To this example, to this
Coordinates of x are -1 and -4. It's 4 and 1, sir. Sorry, 4 and 1.
Coordinates alpha and betas.
Yeah. Oh, y
150.
coordinates. Yeah,
154.
correct.
That's correct.
Yes.
I've not used calculator, so just verify that.
Yeah, that's
Okay.
correct.
Okay. So yeah, you have to find out the. These are the stationary points. You found out these stationary points. Yeah. These 2 points are the stationary points. So find d2 and use it to find the nature. No, I need to find the nature of these stationary points.
Okay. Double derive it. Also, sir, the I I checked the fourth coordinate that the y is not 140.
Good.
It's -10.
Let me see. So 64 times 2 is 48. So, okay, I'm 14 times 60 plus 96. Yeah, it's minus 10. Sorry. Mistake.
Double derivation is 12x minus 30, and when we substitute value of x in 12x, it's going to be one value is -18, other value is going to be 18.
Which one is maximum and which one is the minimum?
Yeah, 18 minima, the uh, minus 18 maxima.
Yeah, so out of these two, which is minimum and maximum? If you comment on these points, yeah.
Okay, so 4 and 10 is minima,
Minus 10.
minus 10, and 117 is maxima.
Okay.
Yeah.
The exercise 7B from the second book as the homework.
Okay.
Should I paste it?
Yes, please. Sir,
Hmm.
in a calculator, if you like press equal to again and again and again, like example 85 divided by 5,
Hmm.
like why does it keep on going like the number is increasing?
By what is increasing or decreasing if you're dividing?
Decreasing.
So it keeps on dividing it by 5.
Keeps on dividing by 5 again and again.
Yeah.
Okay,
Pasting the and also do the chapter review. It's important. Chapter review it because
okay,
all the questions are marked important.
okay.
First do chapter review 8, then do the rest. Okay?
Okay,
This is important. This is important.
sure.
So make sure you do it. If doctor comes ask me the next class. Next class will be solving these questions in which you will be stuck. Or if it's better if you solve them all by your own.
Okay.
I think that's it for today, Vinay.
Yeah, thank you, sir.